So hello everyone, we have created a smart blind stick. This is not only useful for those who are blind, but this device can also be used in scenarios where there is very less light available. So as soon as an object is detected by this stick, okay, an LED which has been connected to the stick will blink, and also there will be some sound produced by the buzzer which has been connected to the stick. We have used the following components in our project: an Arduino Uno, male to female jumper wires, ultrasonic sensor, a 3-volt DC buzzer, an LED, and a 9-volt lithium battery. So now we will just show you all the components that we just mentioned in the video. So here we have our Arduino Uno. Okay. So this Arduino Uno is being given power by a 9-volt lithium battery, as you can see. So here we have the power adapter cable which will be inserted over here, and power will be supplied to the Arduino Uno. So then here we have our main component without which the smart stick will be of no use. We have our ultrasonic sensor over here, right? So the ultrasonic sensor, the 9-volt lithium battery, the Arduino Uno, and here we have the 3-volt DC buzzer. So this is the buzzer, which will produce some sound as soon as an obstacle is detected. And behind the stick, that is on the other side of the stick, we have our LED. Okay, so this LED will blink as soon as an obstacle is detected. So these are the components. Okay, I will just once again go through all of them: the 3-volt DC buzzer, the Arduino cable, the 9-volt lithium battery, okay, the ultrasonic sensor, and the LED. And also all the connections here have been done by using the male to female jumper wires. So all these are the jumper wires which are being used. So these are the components required for this project. So we did face quite a few challenges throughout the project, but we overcame all of them. The first one being the frequency of the buzzer. So the buzzer that came, 3-volt DC buzzer that came from the market, had a very high frequency. So we had to write code to lower the frequency so that the sound was audible, and those who are using a device, they can easily get the sound. The second one being the placement of components. So the components, they had to be placed in such a fashion that the connections, they were all stable, and also had to be placed in the manner that they looked very compact, because the stick had to look very compact. So a lot of time was spent on as to how the components were to be placed. And the third challenge that we faced was that of the external power. So we could not power the stick using a laptop, because that would obviously not be a great design. So we had to use a 9-volt lithium battery to provide power to the stick. So future applications of the project, there is always scope for improvement, and same goes for this project as well. So what we can do is we can add a vibratometer to the stick. So it will be very beneficial for those who can't hear. So as soon as an object will come in front, the vibratometer will give a sensation to the person who's holding the stick, and the person will come to know that there is an obstacle in front of him. So a vibratometer can definitely be added. Secondly, we can go for GPS services. So what we can do is we can connect this blind stick to a GPS, and so the location of the user will be there with the near ones, or with all those mobile numbers to which this particular blind stick will be connected using a software program, right? Then we can also have a panic button. So if just in case there is any panic situation, or maybe the smart stick is there for at a particular location for more than 24 hours, or if the panic button is pressed, so then an alert message can be sent to all those who are to all the near ones, again using a software program. Those will be registered with the stick, and will be an alert will be sent to along with the location to the near ones. So here we have created a smart stick which will be very helpful for the blind, for those who are blind. So basically our project is consisting of a variety of components. First of all, we have the Arduino board here, and Arduino Uno R3, as you can see. Then along with this Arduino Uno, we are using an ultrasonic sensor, and power is being provided to the entire circuit using an external 9-volt battery which is present over here. So as you can see, this is the 9-volt battery over here, and it has been connected using a adapter cable. Okay, So these are the main components of our project, and we also have a buzzer over here. So on detection of an obstacle, this buzzer will basically produce some sound, and we have an LED which is being connected to the Arduino. So on detection of any obstacle, both the buzzer and the LED will produce an output. The LED will blink and sound will be produced by the buzzer. This is a 3-volt buzzer. So we will show you a quick demo of how this entire component, how the entire smart stick works. So here we have the obstacle. Okay, so let's say a person is using the smart stick. So he will, as soon as he will move close to the obstacle, the buzzer and the LED will blink, as you can see. So just coming around 70 centimeters away from the obstacle, the ultrasonic sensor, it is detecting that an obstacle is present. So this is our blind smart stick.